Hello everybody, this is Mr. Mario with another Tinkercad theme lab tutorial. This time we will talk about the slider connectors. As you can see here, I have two automata, one of a cat, one of a pumpkin, and you can see that they are moving thanks to this heart. This will be today's activity, but for the moment, let's start with some theory. So, a slider connector is basically a connector that keeps shapes moving along a line. So you point the slider connector in any direction, and then any shape that is associated with this connector will have this line as a constraint, and it will go forward or backwards following this line. So as an example, we have zip lines like this one, where this ragdoll made with pivot connectors is balancing. So as you can see, here is the slider connector in action. Another example is CAD mechanism, sliding doors, and so on. To learn more about these connectors, today's task will be to create an automaton, simple automaton. So in this case, we'll create this simple cat moving up and down. But first, what is an automaton? An automaton is a puppet or mechanical robot that had like a similar appearance of humans or animals, and they try to replicate some of their movements, and you create them to impress or to entertain people. So automatons they are mostly for art, for entertainment. Here we have two examples. Even robots are not as new as you believe. They are robots from past centuries that were mechanical robots. So basically, they accomplish tasks thanks to clockwork mechanisms. So these are two examples of automata. Here, this automaton is moving using a crank. Now, here for this automaton, we have to talk about a cam mechanism. This is a cam mechanism. Basically, a cam mechanism is a mechanism that transforms rotary motion into linear motion. What's that meaning? That we have here three parts. We have the cam, that is a rotating disc. It can have similar shapes. It have the shape of a pear. It can have the shape of a heart. It can have a shape of a cylinder with an eccentric center of rotation. What is the meaning of eccentric? Eccentric means that the center of rotation is not in the center, is not in the center, is far away from the center. So that creates an irregular movement. If you remember from our previous examples with the axle mechanism, usually we have, let's say, centric centers. Okay, sounds obvious. But the center of the axle was the center of the wheel, or it was the center of the beam in the spinning dogs. But here, the center of rotation is not in the center. We have a follower. Okay, this is the cam, the one that is rotating. Okay. We have a follower. The follower is this lever that goes up and down. It follows the movement of the cam, but in a linear path. So the cam is rotating, and the follower following the cam is going up and down, up and down. Good. A short component is the slide. This part is the slide keeps the follower in position. Without the slide, the follower will fall. If you want more information about CAN mechanisms, I am including a link here in the presentation with very interesting information. Now, here to add the slider component, the slider will be placed here. And as usual with the connectors, we have a blue highlighted part that is the mobile component of the slider connector. It's always dynamic, and this is the one that is going up and down. And the orange highlighted is the base component. It will be the slide of the slider here. Here, like the table where the hole is was created to insert the level, to insert the follower. This is the orange highlighted. In this case, it will be static, but again, according to the mechanism, it can be static or dynamic. Okay. Now, when we create, okay, probably you will ask, why do we need the slider connector if only by gravity we can go up and down? The slider connector keeps the shape on place. Here is using the slider connector, as you can see, reciprocal movement, up, down, linear, up, down, repetitive. Yes. Here without the slider connector, yes, it goes up and down, but it goes stuck, it goes jam, and it falls. Okay. So let's go into action. Let's go to Tinkercad. Don't forget to enter to your Tinkercad classroom. Okay. Now let's start with the project of the day. I'm going to create 3D design. This is a slider connector example. Here, my work plane settings. Let's make it 400 per 400. Okay, close settings. Now I am bringing the ruler. For this exercise, I will need the ruler. You will see that the more the more mechanical are your components, the more complex our mechanisms are, the more you will need the ruler. So I am bringing a box. This box, I will make it 80 millimeters per 10 millimeters per 80 millimeters. Good. I will change the color to something that looks wooden. Perfect. Now, I will duplicate this box. You know how, or this icon, or Command D, or Control D, depending of your laptop. So duplicate. I rotate it. So I rotate it 90 degrees. Good. Let's take it up. You can use this arrow to take it up or down. Perfect. Let's close it a bit here. Let's close it a bit here. Okay. More or less like a table. When I am ready, I will group the components here. Group. Okay. Group the shapes. Now I am bringing a heart from basic shapes. Yes, this heart. As per you remember, the heart is a kind of shape of cams. I will change the color. Yes, let's make it red. I will align to the center. And I am bringing from the SimLab group of shapes, I am bringing here an axle connector. Here, as you can see here, I will align again to the center, here to the middle, here, align to this middle. Good. Now for this heart, the orange component will be the table. The mobile component will be the heart. I needed to be, I need the heart to have a good torque, so I increase it to 170. Motor speed, we can have a little, let's say 30 revolutions per minute. Let's test it in the SimLab. This will do. Perfect. Good. Now I am going to basic shapes and I am bringing a whole box. This is a whole box. I bring it here. Yes. I need this whole box to go through the table here, through the table, as you can see. The dimensions of this box will be 10 millimeters per 10 millimeters here. Good, that will do. 10 millimeters per 10 millimeters of a square. And the height must be enough to cross the table. Again, I select all, I align. Okay, very good. Now for this part, I need to group the whole to the table. So clicking Shift, I click Shift, I choose the whole, I choose the table, I release Shift, and then I group. Control G or Command G, group. Oh. Now you need to be very careful because when you perform operations like grouping and ungrouping in any shape, and that shape was part of a connector, usually they lost that connection. So let's go to let's click the connector. And as you can see, when here the gray circle shows that the connection was lost. So simply we retouch it. Here blue, perfect. And again the table is orange. Good. So if you check, it must work. So remember, don't forget to reattach the connector after performing an operation in a shape. Good. Now I am bringing another box. I bring the box here. This box will make it. If you remember, the whole is 10 per 10 of a square. So this will be a 9 per 9 of a square. And let's add a bit of radius, but just a bit. Good. And let's change the color to white. Okay, let's change the color to yellow for the moment. And I need this. This will be the follower. So I need this follower to be longer. Good, that will do for the moment. Okay, so now I need again to align. So I select all, I click align, align to this middle. Okay, check on top. Okay, here I cannot perform align because this is not exactly the center of the table, but I can click the follower, the yellow box, and move it a bit. Oops, it moved too much. So I can go to snap grid and change snap grid here, and I can change millimeter from 10 to 0.1. So let's move it a bit. Good. This will do. Now it's time to bring the slider connector. We go to SimLab. I click the SimLab. I come here for the slider connector and I bring it here over the table. Okay, you can see here is under the table. This shows the direction of the linear movement. Which one is the mobile part? Again, the follower, the yellow box. I mark it as blue. Which one is the base component? The table is already marked as orange. Okay, let's test. As you can see, it's working. Okay, perfect. Now with this mechanism, you can attach whatever you want. So the exercise say to attach a cat, but it's almost Halloween, so why not a pumpkin? So I am bringing a, sorry, pumpkin. Oh, here, pumpkin. So I am bringing this pumpkin. Okay, let's make here let's make the follower green. Okay, good. Let's bring the pumpkin here. Okay, let's leave it here on the ground. I will rotate it 90 degrees. Using shift, I will make it smaller. If you use a very big pumpkin, probably your mechanism will be out of control. Okay. I am moving it here. I can bring it using align. So I click shift. I select the follower. I select the pumpkin. Align. Remember our trick that after align, after having it ready, you click again the shape that you want to be the center of reference. It will be this one, the follower. So align here, align to the center. Okay, good. Okay, bit bigger, perfect. If you want to use the cat, use the cat. If you want to use a frog or any animal, it's your choice. Good. I am grouping the follower. Remember that this box in a CAM mechanism is called a follower. I am grouping it with the pumpkin. Select both of them. Or do you prefer shift, follower, pumpkin, group? Let's wait until it finishes rendering. When you see this red line here, it means that it's still processing. So you need to be a bit patient. Okay, patience. Perfect, it's ready. But remember, when you perform operations in a shape that is in a connector, usually it loses the connection. So I click the slider here, and as you can see, it lost the connection. So with the gray one, I choose the circle. Sorry, I choose the pumpkin. Now it's blue, the mobile component. And I check the orange, the table. Perfect. Okay. So let's check in the SimLab. Ah, wait. Let's have a bit of fun. Settings. I will change the color of the settings to something more tetric. Good. Gray. Close settings. Here in the SimLab, let's change the ground material. Let's make it concrete. Okay. Color, let's say, why not red? Okay. So remember, something I forgot to add. Exactly. When we were using only the follower, it was not that heavy, but now that I add a weight, it's evident that I forgot to make the table static. Here appears like the dynamic. So table is dynamic. Sorry, table. You must change it to static. Good. The heart is dynamic. The follower is dynamic. This test. Okay. So with this, finish our project. If you want, you can combine the three connectors, the slider, the axle, the pivot, and create your own automata. Thank you very much, dear students. See you next time.